Friends, now we discuss about the another theorem belongs to circus chapter. This theorem states that the lengths of tangent drawn from an external point to a circle are equal. This theorem states that the lengths of tangent drawn from an external point to a circle are equal. These two tangents are equal length when we draw from external point to a circle. This is the statement of the theorem. First we draw one of the circle with center O. PQ and PR are the two tangents drawn from external point P. This is the first data are given are data. A circle with center O, or O is the center of the circle. PQ and PR are the two tangents drawn from external point P. This is the data are given. Next, we have to prove these two tangents are equal. Means PQ and PR are equal. Means PQ is equal to PR. We have to prove PQ is equal to PR. This is the to prove. Next, construction. In the construction, join OP, OQ and OR. This is the construction. Proof. First we consider the two triangle OPQ and ORP, or POQ and POR. These two triangles. We consider these two triangles. We consider these two triangles, triangle POQ and POR. These are the two triangles. In these two triangles, we know that angle Q and angle R, angle Q and angle R are equal. Angle Q and angle R are equal. Angle Q and angle R are equal because the radius is always perpendicular to tangent. Therefore, angle Q is equal to angle R. Angle Q is equal to angle R. OQ is equal to OR because radii of same circle. OP is the common side for these two triangles. When we observe these two triangles, OQ and OR are equal because radii of same circle. Angle Q is equal to angle R because is equal to 90 degree because radius is always perpendicular to tangent. Already we proved in the first theorem. Next one, OP is the common side. In these three, we know that it is a right. These two triangles are right angle triangles. The hypotenuse is equal. Other one side is also equal. Therefore, in a right angle triangle, the hypotenuse and one side of a one triangle is equal to the corresponding hypotenuse and one side of another triangle. Therefore, these two triangles are said to be congruent by RHS theorem. These two triangles are congruent. Therefore, the remaining parts or the other corresponding parts are also equal. Therefore, PQ and PR are equal because of CP/CD, corresponding parts of congruent triangle. In this theorem states the lengths of tangent drawn from an external point to a circle are equal. First we draw the one of the circle with center O. PQ and PR are the two tangents drawn from external point P. This is the data. We have to prove PQ is equal to PR. Construction, join OP, OQ and OR. Next, proof. First we consider two triangles. In these two triangles, the radii are equal. OQ and OR are the radii. Angle Q is equal to angle R, because radii is always perpendicular to tangent. These two angles are equal to 90 degree. OP is the hypotenuse, and also this is the common side for both the triangles. Therefore, by these two triangles are said to be congruent by RHS theorem. Therefore, the other corresponding parts also equal. The other remaining parts for the sides is PQ and PR. These are the corresponding parts of congruent triangles. Therefore, these are also equal. PQ is equal to PR. This is the proof of the above theorem. Okay, we go to next theorem. This is also same theorem, just we discuss about that. This theorem states that tangents drawn from an external point to a circle are equal. This is the first case. Second one, subtends equal angles at the center, subtends equal angles at the external point. This means this theorem having three cases. These are not for the exam purpose. This is not for exam or not for this syllabus. It is removed from your textbook. But in this theorem, only first case is first case for the exam. The second and third we learn about this because of for solving the problems. Therefore, we discuss this theorem. First, we draw the one of the circle with center A. B is the external point. BP and BQ are equal. Already we proved that BP and BQ are the tangents drawn from external point. We have to prove these two tangents are equal. Data, it is also same. A is the center of the circle, B is an external point, BP and BQ are the tangents. This is the data. We have to prove first one, BP is equal to BQ, means the tangents are equal. Second one, the angles subtended at the center, means PAB is equal to PB QAB. PAB is equal to QAB, means the central angles are equal, or AB line bisects the center. Next, central angle. And also the third case says the equal angle subtended, the angle subtended at the external point formed by center joining the center and external point. When we join center and external point, we get the another angle. Angle B is also bisects, means angle PBA is equal to angle QBA. These are also equal. We have to prove in this theorem BP and BQ tangents are equal. The at the center also it bisects, at the external point also it bisects, means in the central angles also having same angles, it bisects. At the external point also it bisects, therefore the external point angles also equal. Next one, construction. Join AP, AQ and AB. Next, proof. Consider the triangles APB and AQB. AQB and APB are the two triangles. By observing these two triangles, AP is equal to AQB. AP is equal to AQ because radii of same circle. AB is the common side for the both the triangles, and angle P and angle Q are the 90 degree. Angle Q and angle P is 90 degree. Therefore, consider two triangles APB and AQB. AP and AQ are equal because radii of same circle, and APB, angle APB is equal to angle AQB. APB is equal to angle AQB because these are equal to 90 degree. Radii always perpendicular to tangent. And third one, the AB is the common side or a common hypotenuse. By RHS theorem, we have to say triangle APB is congruent to triangle AQB. Therefore, the corresponding parts must be equal because these two triangles are corresponding to one another or coincide with one another. Therefore, AB is equal to AP, AP is equal to AQ. The other remaining side is BP and BQ also equal. The other angles are AP, AB and QAB are also equal. ABQ and ABP also equal. Therefore, by CPCT, we have to say first three cases. The three cases also equal. This is the theorem. This is the proof of the theorem. This is not for your exam, but we have to first case only for exam. The second and third is useful for your solving the problems. Next, we have to go to properties of tangents. What are the properties of tangents? Already we learn about this in all two theorems. First property tells from an external point of a circle we can draw only two tangents to a circle. When the point, this is a circle, when the point inside the circle we cannot draw any tangent to a circle, but when the point is on the circle we draw only one tangent. When the point is on outside the circle, when we draw two tangents to a circle, this is the one tangent, this is the another tangent. Okay, these are the two tangents drawn from external point. Therefore, when the point is inside the circle, we cannot draw any tangent to a circle. When the point is on the circle, we can draw only one tangent. When the point is outside the circle, then we can draw two tangents to a circle. These are the properties of tangent. The next property is the tangents drawn from external point to a circle are always equal. These two tangents must be equal length. This is the another property. Next, tangents drawn from external point to a circle subtend equal angles at the center and equal angles at the external point. Means when we join these two lines and radius, when we join these two sides and angles in this same, therefore we know that already know it subtends equal angles at the center. Angle A is a bisects and also angle B also bisects. Therefore, this is the another property for tangents. Next one, problems belongs to circle. The first problem, exercise 4.2. First problem is choose the correct option and give justification. From a point Q, the length of the tangent to a circle is 24 centimeter. Means from the point Q, length of the tangent means from point P. PQ is a tangent. Its length is equal to 24 centimeter. The distance Q from the center means from the center means OQ. OQ is the distance from center to that point. Therefore, this distance is equal to 25 centimeter. Means OP is equal to OP is equal to 20. OP is equal to question mark. We know we have to find the radius of the circle, means OP is the radius. OQ is 25 centimeter. PQ is 24 centimeter. We have to find the value of OP is the radius of the circle. We know that OP is perpendicular to PQ because angle P is 90 degree, because OP is perpendicular to PQ. Already we proved the theorem. Therefore, radius is always perpendicular to tangent. Angle P is 90 degree. Therefore, this is a right angle triangle. OPQ is a right angle triangle. Angle P is 90 degree. OQ is the hypotenuse. Therefore, by applying Pythagoras theorem for this triangle, in a triangle OPQ, angle P is 90 degree. OQ square is equal to OP square plus PQ square. In this triangle, triangle OPQ, angle P is 90 degree. OQ square is equal to OP square plus PQ square. The square of the hypotenuse is equal to sum of the squares on other two sides. By substituting the value of OQ and PQ in the above equation, we get 25 square is equal to OP square plus 24 square. 25 square means 625. 24 square is 576. 576 is shifted to left side. We get 625 minus 576 is equal to OP square. Means 49 is equal to OP square. OP is equal to root 49. Square root of 49 is 7 centimeter, because 49 is a perfect square of 7, means OP is 7 centimeter. Therefore, in the four options, option A is the correct answer. Option A is the correct answer for this question. Okay, we go to next question. The second question is, if TP and TQ are the two tangents to a circle, TP and TQ are the two tangents. TP and TQ are the two tangents drawn from external point to circle with center O. Then POQ is equal to 110 degree. What is the value of PTQ? We have to find the value of PTQ in this problem. These are the four options. This question having four options. Therefore, first we solve the problem. TPQ is equal to TQO is equal to 90 degree, because the radius is always perpendicular to tangent. Therefore, angle P and angle Q are equal to 90 degree. Therefore, already we know that angle O is 110 degree. What is the value of PTQ? If this is a quadrilateral, OPTQ is a quadrilateral. The sum of four angles in the four interior angles in a quadrilateral is 360 degree. Therefore, angle P plus angle O plus angle Q plus angle T is equal to 360 degree. Angle P plus Q is equal to 180 degree. Therefore, angle O plus T is also equal to 180 degree. POQ plus PTQ is 180 degree, because angle P plus angle Q is 90 degree. 90 degree. No, it is equal to 90 plus 90. 90 plus 90. 90 is equal to 180 degree. P plus Q is also 180 degree. Therefore, angle O plus T is also 180 degree. We know that the value of POQ is 110 degree. Therefore, PTQ, write it as it is. Therefore, 180 is equal to 180 degree. Write it as it is. 110 degree is shifted to right side. We get PTQ is equal to 110. 180 minus 110 is equal to 70 degree. In the four options, angle B is 70 degree. Therefore, angle B is the correct answer for this question. Therefore, angle B, the option B, 70 degree is the correct answer for the above multiple choice question. We go to next question. If tangents PA and PB from a point P to a circle with center O are inclined to each other at angle 80 degree, then POA is equal to what? Therefore, this is the P, this is the P. Angle P is equal to 80 degree. Angle P is equal to 80 degree. Already we know that angle A is 90 degree. Angle B is also 90 degree. What is the value of POA? POA. We know that it can be solved by two methods. The first method is POA. 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 This is a triangle. The sum of three angles in a triangle is equal to 180 degree. Therefore, angle O plus angle P plus angle P plus angle A is equal to 180 degree. 180 degree. 180 degree. Angle A is 90 degree. Therefore, 90 degree is shifted to right side. Angle O plus angle P is equal to 180 minus 90 means angle O plus P is equal to 90 degree. Angle POA is equal to 90 minus OPA. Therefore, OPA is shifted to right side. The value of OPA is 80 degree. OPA because half of 80, OPA is half of the angle P because P is also bisects. Therefore, half of P is 40 degree. OPA is equal to is also equal to half of BPA or half of 80 means half of 80 is 40 degree. Means 90 minus 40 is 40 degree. 90 minus 40 is 50 degree. Therefore, option A is the correct answer for this question. Or we can solve this problem in another way is already we know that angle